Morning everyone. Yes, in last session we are completed up to second exercise. In this session we are going to start here third exercise, right? Yes. So before starting in this third exercise, I am going to discuss you some basics. Means what are basics we learnt in this chapter, dear students, in last session? Yes, it is nothing but a decimal expansion, right? Yes. There are two types of decimal expansions. What are those? One is terminating, another one is a non-terminating, right? So if you are, see, I will tell you what is the difference between terminating and non-terminating. Yes. If you are going to division, suppose if you get a reminder as a zero, what type of a decimal it is called as? Yes, anyone? If you are going to division, right? Suppose if you get a reminder as a zero, what type of decimal it is called as? Yes, that reminder, if you get a zero, that decimal where you getting in the quotient, that decimal called as what? A terminating decimal. Yes. Suppose you're not getting a zero and any reminder or quotient, zero means if your division is a never ending or continuous, so on. So what you have to going to say that type of decimal is a non-terminating decimal, right? Children, try to understand very clearly here. By you get in your decimal reminder has a zero, that type of decimal is called a terminating decimal. Yes, clear. When you divide any number, if you want get a reminder as a zero, but your division is continuous, so never ending quotient you are getting, then that type of decimal we call that as what? A non-terminating decimal. See here, I am giving the example here. This is a terminating decimal example. See here, this is a division. The division has ended now. The division have the end now. So this type of decimal we call as a terminating decimal. It is a non-terminating decimal. See here, this division has a never ended. See, it goes on continuing. See, there are two differences in non-terminating decimal. This decimal is a non-repeating decimal, right? It goes on continuous, so on, but it is a non-repeating. See here, this is a 2.6666. What do you mean by this? It is a non-terminating decimal, but it is goes on continuous, but it is what here? Repeating. See the repeating number here, 2.666. We can simply write it as a 2.6 bar. Yes. So like this, some examples are given in exercise 1.3. We will solve one by one. Yes. We have the first question here, 36 divided by 100. So I will tell you how it is given in the textbook. It is exercise 1.3. Write the following in a decimal form. Yes, write the following in a decimal form. We have to write first in decimal form and say what kind of a decimal expansion each has. Yes, we have to write in decimal form and we have to say or write what kind of a decimal expansion in this all examples has. Yes, we will do one by one here. So first one here, 36 by 100, right? Yes, 36 by 100. That was the very first question. So we have to write first in a decimal form, then we have to say that what kind of a decimal expansion it has, right? So 36 by 100, we have to simply divide those numbers. We have to write in a decimal form or in a division form, means yes. So 36 is inside and 100 in outside, right? Yes, you know already how to divide those numbers. See here. So 36 is, okay, I will write 1 second. So see here, 36 is a smaller number to the 100, right? So what we have to need here? So we have to put here the point. So here we have to put 0, means 100, how much 360? 100 3 is 300, right? Yes. See here, The given question was a 36 per 100, but in 100 table there is no 36, right? So how we can write 36 as, we have to put a point here, then we are adding the 0, means now it is a 360, right? So now it is easily divided, or it is see, 100 3s are 300 is the nearest number, right? 100 3s are 300. Then you have to subtract, means 0 6 0. So now the remainder or quotient is here 60. So now tell me, 100 is divisible by 60? No. So what we need to here, we have to add another 0, means we are already mentioning here point, means we have to take already add the 0. So here we taken the point, no, so have to add 0. So what now tell me, 100 how much is 600? Yes, 100 6 is a 600, right? So now we are get the 0 as a reminder. So now tell me what type of division it is. The division is a 0.36 or simply 0.36. So this is 0.36 division. Which type of division it is? It is a terminating expansion, right? This division has ended. This division has end, right? Yes or no? There is a end for the division, right? Yes. So we can write it as a terminating decimal. Terminating decimal, right? Yes. So now come to the second one. The second one has right here. The second one, 1/11. So how do you solve this 1/11? So simply, yes, 1 then 11. So there is an 11 table. There is a one number, no. So we have to, again we have to uh, write here that point and then add what, 10. Now tell me, 11 how much are 10? So it has not also in the table of 11, means we have to add 0, then here also 0. Now tell me, 11 nines are what? 11 nines are 99. So the remainder now is 1, right? Yes. So 100 minus 99 is 1. So same it repeating here, 11 divided by 1 also, here also 11 divided by 1. Then already point is there, so have to add 10. So we need another 0, means 10 is not there in 11 table, means we have to add 0 here, and here below also we have to add 0, means now tell me, 11 how much 99? Now also 11 nines are 99. So now also the remainder left 1. See here, this here 1 and here 1, it goes on continuing, right? The remainder or quotient, but here it goes on continuing. And see here the division is also what, here it is continuing, right? Or repeating. So what type of decimal we call it as? It is a non-terminating. First of all, it is what is a non-terminating, because that the division was what here, not getting 0, it is goes on continuing, and division also what here, it goes on continuing, right? So it is a non-terminating. What type of a decimal expansion it has? It is a non-terminating. And what? See here, this 0.090909, it goes on continuing, means we can write it as in a bar, right? 0.09. So it is a repeating, right? So it is a division is repeating. So next move on to the third one. So third one, in your textbook is a 4 1/8. So it is look like in a mixed fractions. So we have to solve or you have to write in a very simplest form, right? So it is easily. So it's a 8 4s are 32. 32 plus 1 is a 33/8. Yes. So 33/8. How we can write 33/8 here? 33 divided by 8. So now tell me, it is easier one. 8 fours are 32. Then one remainder left here. So one remainder left means we have to need 0 here. So one is not in 8 table, means we have to put a decimal point. Then you have to add 0 here. Then it is a 8 ones are 8, right? So 2 left. So 2 left means we have already have the point, means you have to add 0 here. So 8 how much is 20? So 8 2s are 16. It is a near number. And how much left now? The 4 is left. So already is a point is there. So we have to add again another 0, means it is a simply 8 5s are 40. Now we are getting what a reminder as 0. Now tell me what type of decimal expansion it is. So it is a terminating decimal expansion. Yes, it is a non-repeating, right? See here, the decimal has there is an end of a division, right? So there is an end of a division, right? So this is the terminating decimal. We have to write simply it is a terminating decimal. Third one, terminating decimal. Correct? Yes. Now move on to the fourth one. So what is the fourth question? 3 by 13, right? Yes. 3 by 13. Yes, we have to write 3 and 13 as this side. Yes, tell me. So 3 is not in 13 table, means we have to write the point here, and we have to add 1 0, means 13 how much is a 20, 13 how much are 30? It is 13 2s are 26, and it's a 4 left, right? So 4 left means it's already have the point here, means we have to easily add 0. So 13 how much is a 40, means it's a 13 3s are 39, right? So 1 left, right? So 1 left means we have to add 0, means here the point. So we need another 0, because the number 10 is not in table of 13, right? So we need another 0, means we have to add 0 here, and also in below here also add the 0. So now tell me 13 how much is a 100, means it's a 13 sevens are 91, right? Yes, 13 sevens are 91, means it's a 9 left. So have to add 0, because it is already there in point, no? So 13 how much is a 90, means it is a 13 6s are 78, right? So 13 6s are 78. So now left what? 12. So 12 left. So 12 have to add again another 0. So another 0 means 13 how much is 120? So 13 9s are, yes, 13 9s are 170. So the remainder left here 3. So the remainder is finally left 3, means it is goes on repeating here. So which kind of decimal expansion it is? It is a non-terminating here. See here, it is a repeating. Yes, the numbers or divisions or goes on repeating here. So write down, it is a non-terminating, but what repeating. Yes, yes or no? Non-terminating and repeating, right? Yes. So move on to the next one. That was the fifth one, right? Yes. Fifth question. Fifth question was 2 by 11. So 2 by 11, how we can write a 2 by 11? So simply 2 11. So same as usual, we need a 0, means we have to put a point, 1 point here. So 0. So 11 how much is 20? So 11 ones are 11, means it's a 9 left. We have to add 0, means already taking point here. So 11 8s are 88, right? So 11 8s are 88, means it's a 2 left. So 2 left means now no. We have to add again the 0 means again it's a 11, ones are 11. Then again it's a what left here? 9 left. Then you have to add 0 means again 8. So it goes on what here? The remainder 2 is a continuously goes on continuing, right? So the division is now what here? The repeating. So this is the what type of expansion? It is a non-terminating, but what here? Repeating, right? Yes, repeating. So sixth question is there. Sixth question is a 329 by 400. Yes, so students, you have to do by your own. Yes. We move on the second here. The second question. Yes. You know that 1 by 7 is equal to 0.142857, right? See here. What is this means on this bar? It is the 1 by 7 is what the division is repeating, right? Yes. Can you predict what the decimal expansion of a 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, or without actually doing the long division? If so, how? Yes. So here there are already given one example that 1 by 7 value is this much, right? So this value or this division is a repeating division, right? It is a repeating division. So like that, we have to find with which numbers here? 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. We have to find out these values also, right? Yes. So the condition is without actually doing the long division method. Yes. Okay. This one is finding value 1 by 2, 7 by careful. Yes. This is a hint they are giving. Yes. Move on. The second one. Yes. It is they're given the one example that 1 by 7 is equal to 0.142857, right? So it is a repeating division. So we have to find out values of 2 by 7, 3 by 7, yes, next 4 by 7, 5 by 7, then 6 by 7, right? Yes. So see here, they are already given 1 by 7 value, right? So we have to simply multiply this 2 by 7 into 1 by 7. Yes, 2 into 1 by 7, correct? We need to find out a 2 by 7 value means they are already giving 1 by 7 value. So with the help of that given value, we have to find out a 2 by 7, right? So it is simply 2 into 1 by 7, yes or no? So now tell me, 2 into what is the 1 by 7 value given here? The 1 by 7 value is here 0.142857. Now tell me 2 into 0.142857. It is simply, yes, 2 sevens are 14 means, yes, 2 sevens are 14. Yes, then 2 fives are 10, 10 and 7, yes. Then it's 5, yes, then it's 8, then it's 2, then it's 0.285714 on this bar means the bar, the meaning is the division is repeating, right? So like that, so on, you have to find out 3 by 7. So simply 3 into 1 by 7. So 3 into what is the 1 by 7 value? 0.142857, right? So what is this value? You have to multiply 3 into 0.142857. You will get the answer as 0.428571 bar. We'll check the answer later, okay? So what is the 4 by 7? So 4 by 7 is a 4 into 1 by 7. So what is a 1 by 7? So 1 by 7, the value of 1 by 7, here what? That's 0.14257, right? So simply it is also 4 into 0.14257 as as. So what is the answer now? 4 into 0.142857 is a 0.571428, right? So like this, 5 into 1 by 7 and 6 into 1 by 7, then you know the answer. Yes, do your by own, dear students, and find out these answers. Yes. So we have to uh, move on that. The third one here, express the following in the form of p by q, where p and q are integers and q is not equal to 0.